המציג הבא שלנו הוא דן עמנואל קאץ, נכון? במקור מגרמניה, למד תעשייה בדגש על לוגיסטיקה ושרשרות אספקה, היום בתואר שני בשרשרות אספקה בבר אילן, ודובר איתנו על נושא של הליכתיות.
תודה רבה. I'll hold the presentation in English. I hope that's fine. It's easier for me and I think I can express myself better. Yeah, my name is Dan. I'm from Germany, from Frankfurt. I'm going to talk about the analysis that we're conducting about incorporating more walking into using public transportation. This research is funded by the ISTRC, and first I'm going to talk about the motivation and the objective, what is the background of the research and the analysis, and the goal of it. Then I'm going to explain to you the methodology that we used and that we developed. After that, going to the case study that we applied the model on, and in the end, the conclusions and the results that we took from our analysis. First of all, like Svetlana said already, improving public transportation is a very important part of society. It makes our lives easier. We want to see a big shift from vehicles on the streets to public transportation. It's a very important thing to do. It makes, again, our lives easier. Public transportation is the environmentally more sustainable form of transportation. And on the other hand, we have walking. Walking is healthy for us. It's good. It improves our well-being, not only physically but also mentally. Myself as a person that likes to walk and that uses public transportation a lot, not only here but everywhere I go, I can say that it's a good thing. And the ultimate goal of this analysis is to obviously improve accessibility and connectivity of the public transportation system. We want to see how does walking affect the public transportation system and how does the change of walking affect our transportation system. So the general methodology of our analysis can be seen here. The whole model relies basically on one simple software, which is called OpenTripPlanner. And the end of the day, it's a basic trip planning tool like Move It or like Google Maps with a small difference. It allows us to extract trip data and to analyze it and to organize it in our own tailored way. It makes us as a user or as an analyst our lives much easier. It works with two different file types. The first one is OpenStreetMap, which is basically just a map format and GTFS. I will shortly talk more about these two data types. Then we apply a simple Python script to OpenTripPlanner to extract the trip data. For that, we will need to input origin and destination pairs that can be chosen. And then we also have to input a time window, basically. When do we want to see the trips? And what's the time window, basically? Do we want to see it in the morning, for the morning peak rush hours, or in the evening? And in the end, what we get as a result is a big list of trips, a huge file of trip data that contains a very detailed breakdown of the trips. How much time do we take from A to B? How much time do we walk? So this way we can ultimately analyze walking data. So, like I said, what's OpenTripPlanner? It's a multimodal trip planning tool. It's open source. It's free. You can just go to the internet browser and download it. In the end, it's a API server that we run on our local computer. It integrates various data sources, including schedules, geographic information, and real-time updates, with the goal to provide accurate and up-to-date route planning information. So, since the data that we're using is open source, it's very easy to integrate it into several systems and softwares. Some of you might know General Transit Feed Specification. It's a type of data that government agencies or public transportation providers provide and upload to the internet that anyone can just download. It allows transit agencies and also private people to create applications and services or conduct analysis, just like we're doing. And we will see in a minute what these files contain. This is the way it looks like. It's typically a zip file that you download. It contains several text documents with data about the public transportation system. And as you can see, it's very easy, understandable. Data about the routes, about the stops, about the fare, and so on. This is the way the actual file looks like. One of them, as you can see, it's the stops file that contains data and information about bus station stops, like the stop code and stop ID, also the coordinates of the bus stations, which enables us to do spatial analysis also with geographical analysis tools such as GIS or ArcGIS. And because it's standardized, it makes it easy to analyze data. In the end, the second data type that OTP uses is OpenStreetMap. It's also open source. Again, we're only using free data here. We don't have to beg any institution or company for data. In the end of the day, it's crowdsourced data collection, and it allows individuals and agencies to contribute and to edit map features. At the end of the day, it's basically map files. Here we can see when we apply the Python code to extract the data, we have several request parameters. As you can see, it's very easy to understand. We provide the date, the mode that we want to see, here the transit and the walk. We don't need a specific time that we arrive by, and here we can see the coordinates from our origin, the coordinates from our destination, and the time that we want to extract the data for. So this is the request data in JSON format, and scrolling down we can see the response data. There where you can see plan, this is actually the actual trip option that we get. It gives us a very detailed breakdown again of the whole trip. When do we walk, how much do we walk, where do we have to transfer, where's the location. You can see here the coordinates of the bus stations on the bottom, for example. The time format is in Unix. It's a format that we basically cannot understand just by looking at. That's why we change it with the Python code to a time format that we can choose from. And when we extract the data, these are the parameters that we want to see. Obviously, we want to see the trip start time. When does the trip start? Then TTI is the total travel time for a itinerary. An itinerary is basically a trip option. The total travel time consists of these other small parameters that you can see in cursive there. The ingress walking time is the time that we walk from the origin to the first bus station, basically. The next three parameters are self-explanatory, I think. And the egress walking time is the time that we take to exit the public transportation system, meaning from the last bus station that we alight from the bus to the actual destination that we desire. Along with that, we have the number of transfers, basically how often do we transfer for a trip, and obviously the boarding and the alighting stations, along with the coordinates of them to, again, do some spatial analysis. This is the way the user interface looks like for OTP. Again, it's basically like Move It or like Google Maps. On the bottom left corner, you can see 19 itineraries returned. So if you would click on it, we could see the exact breakdown of the trips, how long do they take, what are the options, and so on. All right, so in order to get a more realistic set of data, we want to eliminate trip options that are unlikely to take by the passengers. So we have a huge data file with a lot of trips, and obviously there are some that are unrealistic because they have either a very high walking time or a very high total travel time or whatever for transfers. That's why we apply the Pareto font identification. I'm not going to go much into detail here because of the time, but On the graph, you can basically see it just filters out or flags trips that are inferior, meaning trips that are unlikely to be taken by passengers. So all points that are in red, we're not considering for the analysis. The points in blue are is the Pareto front, basically. These are the points that we actually consider, and it's important to understand that we can just flexibly change the objective, such as here we chose the walk time and the total trip time. Here it's called duration, but it is actually the total travel time. And we can technically also take the number of transfers instead of the walk time, for example. But since we are analyzing the walk time here, we want to include that. So that was basically the whole outline of the model that we're using. Now we want to present to you the actual case study, the actual analysis that we conducted. So here on the map you can see basically all addresses, home addresses of Bar-Ilan employees, anonymously, and which was approved by all committees, obviously. So we're using this set of origins for the analysis, and as a destination we're using the Bar-Ilan campus. I think it's will show us big insights on the system itself, because we have short distances, we have far distances, and again, this is something that we can flexibly change. We can obviously just take out some origins and eliminate them, or add others. It's also important to understand that we can apply this model to any location that we want to, since again, every public transportation data, every public transportation agency provides this kind of data. So here we can see the Excel text file that is basically the trip data that we have. We can see here on column K the total travel time. Here, for example, we can see we have two trips. One has 78 minutes, the other one has 82 minutes of total travel time. The one with the shorter travel time has more walk time. So here we can see the first insight that it can actually happen that more walking can be beneficial for the efficiency of the trip. Then we aggregate the data by walking thresholds. Here, as you can see in column D, we aggregated the data for 100 meters, for 500 meters, and then so on in steps of 500 meters. Then we got the average and the average values and the standard deviation values for each of the parameters. Here we can see the network summary. Let's focus on the second table, because that's after applying the Pareto front identification. We can see that the more we walk, first of all, the more trip options we have. It's the second column. If we walk 500 meters, or if we're willing to walk up to 500 meters, we have around 4,000 trip options for 1,000 origins that we chose from basically the addresses from Bar-Ilan University employees. And we can see the more we walk, the more options we will have. Although the biggest jump is from 500 meters to 1,000 meters. What's also interesting to see is that the more we're willing to walk, the less number of transfers we will have. Here we can see the number of trip options that rises, like I mentioned, with each walking distance. There's a huge increase between 500 and 1,000 meters, like I explained before. Here we have a decrease of around 10% between 500 and 1,000 meters of walking, meaning if you're willing to walk 1,000 meters instead of 500 meters, you're much more likely to transfer less often. Also, the waiting time decreases with each increase of walking distance threshold. So, as you can see, it's not much, but it's something. Here we can see the breakdown of the travel times. On the left side, you can see the breakdown of the total travel time. How much time do you spend in transit? How much time do you spend walking? How much time do you spend transferring or waiting for the next bus? On the right side, we can see the breakdown of the walking times, meaning how much do you walk to the actual first bus station, how much time do you walk transferring, and how much time do you walk home or to your destination, in our case, Bar-Ilan campus. Here we can see the alighting bus stations at Bar-Ilan campus. Basically, the left side shows us the alighting bus stations for walking up to 500 meters, we have 4 stations as you can see. On the right side, if you're willing to walk 1,000 meters, we have 3 extra bus stations that come up. At the end of the day, you can choose which one you want to alight at. Here, the last visualization. This is a neighborhood from Jerusalem. We can see the dots, the points that are circled in red are origins that have a big change in total travel time. The numbers that you see are the total travel time to Bar-Ilan campus. You can see if you're willing to walk up to 500 meters, you take 95 minutes around to your destination. But if you're willing to walk 1,500 meters, on the right side you can see it decreases by 40 minutes to 81 minutes of total travel time. And as a comparison, on the bottom you can see the average car travel time from this area is 55 minutes. So we can say that in the end of the day, walking is healthy, it promotes physical activity. We want to increase walking in public transportation. It can reduce travel time, the overall travel time. It can also give us more options, which makes us more flexible as a passenger. We can choose more regarding our own choices. Maybe some people want less travel time, maybe some other people want a more direct trip with less transfers. So they can, if they're willing to walk more, they have more options, they can choose more. Also higher reliability. If they miss a bus, they're obviously able to take another one if they're willing to walk more. And as we saw before, less transfers and less waiting time. Thanks a lot for listening.
אפשר בעברית?
אפשר, אני אנסה.
טוב. אתה אומר ש500 מטר הליכה יביאו אותי ליותר הזדמנויות תחבורתיות ציבורית, נכון?
כן.
בשאר העולם זה גם 500 או שזה פחות או יותר?
אני לא בטוח אם באמת הבנתי את השאלה, אבל זה אומר שאם אנשים מוכנים ללכת יותר ברגל, יהיו לכם פחות transfers ב-waiting time.
השאלה היא במקומות אחרים בעולם, זה גם 500?
זה כאילו אי אפשר להגיד כי יש, כאילו עשינו את הניתוח רק לבר-אילן, אז כן, זה רק את ה-case study שעשינו.
אני אולי אוסיף, המספרים, הטרשולד, עניין של קביעה, זה יכול להיות בגבול המדיניות. במדינה, תכנון המרווח בין תחנות הוא 500 מטר, 600 מטר, 400 מטר, אפשר להתאים את זה. ומאחר וזה open source ו-open data, אפשר להריץ על הכל מקום בעולם, בהנחה שיש לי מוצאים ויעדים. אבל אני יודע שתקבל תוצאות דומות.
אני יכולה להוסיף שלפי הספרות זה עד 300. אז כאילו מ-500 אתה בעצם פותח להם יותר.
As I understand, you didn't use real-time data here.
This data was taken from, I think it was the 31st of May between 6 and 9 a.m.
It's not real.
It's not real time.
No.
Because real-time data can influence the traveler's decision very
Of course, yeah.
heavily. Because if I see that the bus is the expected time of the bus, for example, is in an hour from now, I will walk. But if it comes in 5 minutes, it's a different decision.
Of course, yeah. Obviously, it depends on real-time data. It changes the analysis in some way.
And I comment on that for the first presentation in the morning, when the Israeli digital government will provide archive data or ABL data, we'll be happy to use it.
You have it.
No, ABL data, archive, no Siri, which is real time. I mean, historical data. Historical archive, bus, trips, data.
Yeah, but you can archive the series.
Myself?
Yeah.
Why should I?
I think she will never have to give a lecture at this forum again after the questions she was asked this morning.
those places?
Walking facility?
Walking facilities. Is there a shadow? What is the weights of the pavements?
עלייה או ירידה?
It is possible to do it with OpenTripPlanner. It for sure considers this, yeah, but in this analysis we didn't look at this kind of data now. But it is possible to do it with OpenTripPlanner.
1,500 meters in a highway is not like
Obviously, it
1,500
depends.
meters in an urban
It
area.
depends, yeah.
But in this study, you looked only on the distance, not the character of the walk.
No. There's a standardized walking speed that OTP sets, and also this is adjustable. I think here it was chosen 3 miles per hour as an average, and yeah, it's a good question.
I have a question, very nice presentation. I have a few questions, but I will just ask one. You checked more walking at the origin, basically.
No, it's the overall walking. It's not only
both origin and destination.
Exactly. It's the overall walking. It can be the ingress walking to the first bus station. It can be the transfer walking. It's the overall walking, not only the beginning.
Okay, so I will ask you another question. I understand this is a supply side analysis, basically. But did you try to ask Babylon employees if they're actually willing to walk the extra distance? Because from your map, it seems that most of Babylon employees actually take the car.
Probably yes, because a lot of them live outside of the Merkaz. So yes, and no, we didn't ask Bar-Ilan employees if they are willing to, or if they actually use the public transportation system. No. You're welcome.
Thank you very much.
Thank you.
Of course.